Hello students, in this video I am going to demonstrate the experiment number 3 where pilot operated check valve is used to hold the long time suspended loads. Okay, that is experiment number 3. Title is mechanical locking by means of momentary contacts, switch contacts. That means sorry, this is experiment number 3. First, I'll tell you the background of the circuit, and then we'll go to the simulation of this hydraulic circuit as well as relay circuit. The name itself is like indicating that it's a mechanical locking of loads. So some applications are there. For example, you can see this application where in the service station, car service station or truck service station, where it needs to be lifted upward for servicing, right? Where service may take, for example, 30 minutes, 1 hour, or more than 1 hour. So that heavy load is holded in certain position for long periods of time. And one more application is again hydraulic cylinders used in dam gate control applications where the heavy load, its metal gate is held in certain position for long periods of time by the hydraulic cylinder. Here, biggest challenge is holding in that particular position without changing the position of the load due to gravity. Okay, so full weight is acting on that. So the position should not be disturbed because of its heavy weight. Okay, so let me explain more with a simple circuit. Right, so open the FluidSim software, run. New sheet. So again we are discussing background here. First we'll take a actuator. So generally we're talking about the cylinder in vertical condition, say for example horizontal or sorry vertical condition, and I want it in downward, so I can make it, yeah, this is the right position. Assume that there is a load here, say very large load is attached here. Say for example M, that is mass, very large mass is attached to the cylinder, and that is being controlled by for example direction control valve, which is solenoid operated. This is 4x3 direction control valve. 3 positions are there, 2 solenoids are there, and this valve, so I want it this side. So AB is connected to actuator, A and B. Okay, and pump you can consider as the fixed displacement pump, and then tank. So tank line is required here also. And next, since we are using fixed displacement pump, protection is required, so we should have the proportional valve, sorry, pressure relief valve, pressure relief valve. I did the protection here, and one more tank line is required here. So I should use pressure gauge. So pressure gauge is available in measuring devices. Fine. This is a very simple circuit, just we are discussing only the background of the experiment. we're not discussing the exact experimentary. Here we should understand why we should use pilot operated check valve. There are two types of check valve: a simple check valve or pilot operated and pilot operated check valve. That is the discussion we are doing here. See, this is a very simple experiment. There are three positions are there. There are two solenoids called Y1, Y2. Okay, so all of you, you know the concept, right? When solenoid Y1 is on, what is the flow configuration? Flow configuration is, it is called P to A connection will be there, and B to T flow takes place. So this is when solenoid Y1 is on. Okay, so same thing when Y2 is on. What is the flow configuration? P to B, and A to T. This is a flow configuration. So there is a third position, right? So when solenoid Y1 and Y2, solenoid Y1 and Y2, both are off. Then what is the flow configuration? Flow configuration is all ports are blocked. That means there is no flow, no flow to A or B. Okay, so to be precise, Y2 is on. This is Y1 is on. So when Y1 is on, P to A, B to T. When Y2 is on, P to B, A to T. When Y1, Y2 both are off, all ports are blocked. That is a middle position or neutral position we call it as, or home position we call it as. There is no flow. So no flow means actually there is no movement. Okay. So to be precise, more precise, in this circuit, as per the connection, if solenoid Y1 is on, means it cylinder will move. It's a downward movement. Cylinder moves in downward direction. Downward movement. When Y1 is on, downward movement. Same thing, in the same way, when Y2 is on, it is a upward movement. So in the same way, when solenoid Y1 and Y2 both are off, with respect to the connection what we made, is cylinder movement is, or we can say movement is stopped. So what is the meaning is, when Y1 Y2 both are off, cylinder is in stop motion. When Y1 is on, cylinder moves in downward. When Y2 is on, cylinder moves upward as per the circuit. Right. So what I'm trying to tell you is, if you go to the simulation, right now the solenoid I have not connected, but I can manually switch on the position. If solenoid Y1 is on, assume that if solenoid Y1 is on, so cylinder is moving downward, and now it is in certain position. Okay, so cylinder means in the piston is not in top dead center, it not in bottom dead center, it is in intermediate position. So this is the position required. You need to hold this position, you need to hold the very large load for a long period of time in this position. So position should not be altered. Okay, so what you can do it is you can stop at this position, even you have to hold it, right? So right now the point is, say for example, according to the understanding, if both solenoid y1 y2 both are off at the time at the time now, so all ports are blocked. So since all ports are blocked, movement is not possible theoretically. Okay, so graphical symbol also tell the same thing, so there should not be any movement. But what happens in practical, this is a spool operated valves. So spool operated valves, this is a spool operated valve. In spool operated valve there are two types of valves, spool operated and puppet operated types. So this valve is spool operated. Spool operated valve, spool operated valve. The feature of spool operated valve is it is having an internal leakage. Okay, so it is comparatively the low cost compared to pilot operated valve, but uh, it is low cost compared to pilot operated valve, but it is having internal leakage. So to be more precise, so internal leakage, that means why internal leakage? So spool operated valve spool operated valve will have a obviously spool. So in order to spool slide in the valve, there must be a radial clearance. Because of radial clearance, what happens? There must be a small leakage. There could be a small leakage from P to T or P to A to P, A to T. So it's like wherever low pressure line is there, then oil flow from high pressure to low pressure, right? Especially what we are talking about is this is crossing the lines. So okay, so here that is a concept. So because of internal leakage, what happens? The small amount of oil from the rod chamber can leak to tank because of radial clearance. Okay, so because of internal leakage. Assume that if pump is off, for example, you have locked the position of the load. So assume that you have switched off the pump, but you are holding the load in certain position. So pump need not to be on. So you are hydraulically holding that position. So what happens? There could be small leakage from the rod chamber to the tank. So what happens? There could be some small movement, that is creep movement we call it as. So very small movement will be there in the downward direction. So if you keep for long hours of time, maybe few hours, so your expectation is load to be hold in that particular position, but after certain time, so load will be completely down. That means there is a movement of cylinder because of the attached load. So this should not be done, otherwise it will create accidents, right? So you have to hold in that position firmly. So for this application, we should avoid the leakage from the valve. So how we can avoid the leakage from the valve? Very simple. The thing is that flow control valve. In flow control valve, check valve is there. Check valve with spring you can take it, spring or without spring. So with spring it is used. So here assume that. So what I'll do is there is a leakage here, but if I put a check valve here, is that going to solve my problem? It is avoiding the leakage. See, it is right now I've added a check well here. Check well, what is a check well? What is a check well function? Check well is check well allow the flow only in direction from A to B. Correct. Check well A to B flow is possible. The same way B to A flow is not possible. Right? It's a simple check well. So I'm going to keep it this bottom here. So we are discussing this one. By having check well here, it is not going to solve the problem. It will avoid the leakage, but permanently there is no flow from B to A. That means cylinder not able to move downward at all. Okay, so this is not going to solve my problem. Check well is assumed to be perfect leak proof valve, but still it's not solving my problem. Internal leakage is avoided completely, but downward movement of the cylinder is not at all possible. I want downward movement of the cylinder plus internal leakage should be avoided. How? So that is what. There is another check valve called pilot operated check valve. It's a pilot operated check valve. There is additional port called X. Okay. So here a pilot operated check valve works same as simple check valve. So let me put as a simple check valve. And what we're discussing is pilot operated check valve. It's also called PO valve. Sometimes in short we call it as PO valve. So the flow condition is normal. A to B flow is possible. B to A flow is possible, but with a condition. Flow is possible if X equal to high pressure, or we can call it as high pressure, also called as P. B to A flow is not possible, again not possible if X equal to T, means low pressure line. It is like high pressure, this is low pressure. Okay, so there's a special valve which the third port is there, X port. So we can use this valve. So with a certain condition, that means it will work like a normal check valve, but with a certain condition only that valve can open and downward movement is possible. Okay, so we are going to use a pilot operated check valve instead of simple check valve. So I'm going to delete this, and then we can go for pilot operated check valve. So I want it in this direction, so 180 degree. Yeah. So X, what I'll do is see, whenever you want a downward movement, what is the condition when Y1 is on? P to A. So A line is high pressure. I know that A line is high pressure, right? So what I can do is I can connect this X to A. That is one possibility, but that is not used for this kind of valves. For this kind of application, we should use different types of spool called J spool. This is a E spool. That the floating center valve should be used. For this kind of valve, we cannot connect X to A line. It's not recommended because it is not going to solve the problem. So externally, we should use external oil pressure, so that whenever we want to have a downward movement, it is to be operated. But right now, hydraulically it is locked. That means when cylinder is in intermediate position, oil is not able to flow. Even in cylinder is in top dead center also. See, oil is not able to come out of the cylinder because check valve is there. It is completely locked. Okay, so even though there is internal leakage in the valve, but there is no leakage from the check valve, period operated check valve. So hydraulic cylinder is firmly hold. So cylinder can hold the load in particular position for long period of time without any change in the position. Okay, so that is the understanding. So we are going to use pilot operated check valve. Okay, so when coming to the assignment here, this is a hydraulic circuit for exercise 3. So there we are using the G spool valve, that is tandem center valve is used here. That is in middle position. P and T only connected, but not A and B. Okay, so let us come to this. See, solenoid Y1 is there, Y2 is there. When solenoid Y1 is on, cylinder will move upward here in the circuit given in the manual, that is given, that is upward, but we have taken as a downward. Okay, uh, it's okay. We'll stick to the application here. This is only for your understanding. This is a background. Okay, exact circuit we are going to start now. So by okay, so now right now I'm going to close this. I'll start from the beginning because it is only for 30 minutes. Run. Okay, so hydraulic circuit, that is actuator. We're using double acting cylinder and then rotate. This is a cylinder, and we should use 4 by 3 direction control valve. So direction control valve, solenoid operated. Yeah, 4 by 3 tandem center is available here. This is a tandem center. Okay, see the circuit here. A is connected to the rod chamber. A is connected to rod chamber, and B is connected to the piston chamber via pilot operated check valve. So DS1 is a pilot operated check valve, and DF2.X, that is a throttle check valve. Okay, so throttle check valve, and first we'll take pilot operated check valve is available in flow control valve. So pilot operated check valve is available here, and let us orient the cylinder like this. That means I'll move in this way. It should be good. And sorry, sorry, this is the one I'm looking the orientation. No, this is rotated by 90 degree and mirror vertically. Yeah, this is a fine. So here, as per the, it is above, right? So we want it in, yeah, this is good. So A is connected to rod chamber, and B is connected to parallel operated check well, plus throttle check well is available here. So what is the direction? It should not allow flow from piston chamber. Okay, and A is connected to B. X is not connected there, and we should have a pump, then tank, that is the same circuit, and protection circuit should be there. So that is pressure relief valve, we should use it in the P line, and tank should be available here. So pressure gauge, you can have it as usual. It is available in the measuring uh, instruments. So this completes. Okay, there is one more. So we have to supply hydraulic coil to the export, right? That is from externally. So for that, to have a high pressure and low pressure control of export, then we should use another valve. Okay, that is another DW3E, that is a 4x2 direction control valve. Why? Because in the laboratory, 2x2 valve is not available. Oh, sorry, 3x2 valve is not available. So 3x2 valve is enough actually in this for this application, but 3x2 valve is not available in the laboratory. So we are using 4x2 as a 3x2 valve application. Okay, so we are we have to use solenoid operated 4x2 direction control valve. Yeah, this is a valve, but we don't we should not use the port A here. Okay, so we have to block it. So to block, double click on the port A, and you should select it as a terminator. That is a terminate means the flow is not possible. See, I have terminated A. Okay, so B, what I'll do, B I'll connect it to X. Okay, so P should be connected to P line, and T should be connected to T line. That's the same connection. So meaning is, now there is a new solenoid called Y3. If solenoid Y3 is on, say right now solenoid Y3 is off, right? What is the flow configuration? Let me explain this. Draw text. Now Y3 by default it is off. If Y3 is off, what is the flow configuration? P to A and B to T. Right now it is off. So since B is connected to tank, B pressure is tank pressure. Since B is connected to X, X is also tank pressure. Okay, so I'll have more meaning here. See, B equal to T, B equal to X, and B equal to X, and also B is also connected to tank. So what is the meaning of from these two equation? So that nothing but X equal to tank pressure. X equal to tank pressure. This is a very important thing. So like that, another condition is when Y3 is on, flow configuration is P to B and A to T. Now B equal to X, but B equal to P, because there is a change. So what is the meaning from these two equations? X equal to P. X equal to P. So now that means when Y3 is off, the condition of X is tank pressure. When Y3 is on, the X pressure is high pressure. So there how whenever you want to have a downward movement, whenever you want to have a downward movement, you can switch on Y3, and whenever downward movement is not required, that means if you want to hold firmly, you can switch off Y3, so that oil leakage is not possible from the direction control valve, because oil itself is not coming out of the cylinder. So there is no leakage in the cylinder. You can use a spool operated valve, so that still you can hold the load, and cylinder can hold the load firmly for long duration of time. Okay, so this remember. See here, when solenoid here, if you refer the configuration here is Y1 is means P to A and B to T. So configuration is straight here. So here cross is there. So I am going to change that connector. Let me see. Can I change the position? Yeah, position settings. Connector configuration. Yeah. In the left side, I want straight. In the left side, I want straight. In the right side, I want cross. So that only I'm changing. Okay, because it has to match with our manual. Okay, so now, so we completed the hydraulic circuit, but now the relay circuit is pending. So relay circuit is here. So there are two switches are used. Here signal storage concept is not used. There are two switches called S5 and S9. You can name it like S1 and S2 also. Two switches are there. So each one switch for upward movement, one switch for downward movement. Okay. So in this circuit here, so when solenoid Y1 is on, see here, when solenoid Y1 is on, P to A, that means it's a downward moment. So when solenoid Y1 is on, downward moment. So downward moment should be possible with only condition of Y3 on. If Y3 is on, then only the downward movement should be possible. Otherwise, it's not possible, because X pressure will be always low pressure, because B is connected to tank when solenoid Y3 is off. Right. So what is the condition of downward moment? Solenoid Y1 should be on plus Y3 should be on. For upward moment, only Y2 is enough. The condition of B is not required, because whenever solenoid Y2 is on, P to B, and oil can flow easily from A to B without any condition of X. So it is a bypass valve. Okay, it is bypassing the flow of X, means X condition is not required. So what is the condition? To move downward Y1 and Y3, to move upward only Y2. So this is the condition we have to build in the relay circuit using relay. Okay, so now, so one switch you taken. So in the laboratory, see, you can observe in the laboratory, one switch can be used normally open as well as normally closed, right? So that switch, that is the indication. This one is 9, we are using as a normally closed as well as normally open. Same switch can be used. So let us see whether it in the laboratory it is there or not. So go to the electrical circuit, IEC standard, power supply, 24 volts. Okay, and we'll take a switch that is mechanically operated. We'll take S5 as a normally open switch. We'll give the same name as it is, S5, and I will display it. Okay, and next we'll take a switch which can be used as normally open as well as normally closed. Let me see that is there or not. Yeah, crossover switch is there. Let us see. I can use one switch as normally. No, this is both are normally closed. Okay, no problem. We'll use one uh, normally close. We'll use one normally close here, and normally open once again. We'll use it, and go to the relay. The relay section. There is a coil. Is there? This is the K1. Assume that I'm using S5 for upward moment. So for upward moment, what is the condition? Only Y2 is enough, right? So K1 is for upward moment, and take the general switches, that is normally open contact, and this is for K1, and I have to take one solenoid. How many totally? There are 3 solenoids. So this is solenoid Y2. So it will move upward when solenoid Y2 is on. But for downward movement, we have to operate S9 switch. S9 switch. So this is also S9 switch. Okay, so S9 switch is used. Now by operating S9, K1 cannot be on because it's normally closed. But by operating S9, sorry, this is not should be used. This should not be used. S9 will take another relay called K2. Here K2, and you can take it here. It's the same. So both are S9. So when you operate S9, it is going to cut off the power supply to K1, and so it will switch on K2. So what is our requirement? When K2 is on, we have to switch on. Both are K2. This is K2, and this is also K2. Both are K2, and you can go for the solenoid. This is solenoid. This is solenoid Y1. Solenoid Y1. This is solenoid Y2. Sorry, this is solenoid Y3. Y3 and Y1 should be on at the same time. y3. Okay, so now go to the simulation. So here by operating S5 it will move upward. So downward movement you have to operate S9. See, can you check the condition of X? When Y3 is on, P is connected to B. So since B is high pressure, X is high pressure, and C valve is open. So when Y3 is on, then only it will allow the flow in downward direction. That means it will allow the flow of oil out of the cylinder from the piston chamber. So uh, in this condition, say for example upward, this is an intermediate position, not upward, not downward. So now the oil which is under the piston, it is under high pressure because heavy load is acting on that. It's tried to come out. Okay, but B to A flow is not allowed. Why? Because X is low pressure. Because X is connected to B, B is connected to tank. So now hold is firmly holded for firmly in that position for long periods of time because there is no leakage. This is how this is demonstrated. This experiment, and we can save. Okay, save feature is not available in demo. You can save the circuit and the Word file and submit the assignment. Okay, if you like this video, please subscribe my channel. Thank you everyone. Thank you very much.